Hey everybody, this is Mark. I'm going to talk to you a little bit about the Synchronous Motors Lab. What I've done is I've already gone through doing the test with no load, and I've now hooked up the generator, and I'm going to be going through just real quickly some key points where students often find themselves hung up. So one additional note, you guys, and that is that you will not actually be connecting any resistors or anything up to this lab. What I've found is that 7 newtons, which is what the lab calls for, is too much. And that 7 newtons was a combination of just the generator and some additional load. You will not be hooking up any additional load in this case.
Okay, now we've connected the dynamometer. Now, the lab calls for 7 newtons. I've tried this, and there's just no way you're going to get 7 newtons of force on this thing. When we turn it on, you're getting anywhere from 3 to 4 newtons. That's lots for this experiment. All we're trying to do here is to show you the load current. Load, again, meaning armature current with a little bit of load. Now, because we have a generator connected here, we're also going to make sure, of course, part of this deal is you have to make sure there's a voltage at your generator. If you're not generating a voltage, this lab isn't going to work. So when we start this up, we got to make sure that we're generating a voltage. So you can see here that I have a short shunt cumulative compound generator hooked up, and this is not separately excited. This is self-excited, and I do have the rheostat turned up so that we are producing an output voltage of 120. So that's really the first thing you need to do. We're going to turn this on, and we're going to make sure that we actually are producing that right voltage. So we're at about 115, so we need to adjust this until we're reaching 120. So there we're at about 120. So that thing's producing 120. So we're good there. Now, this particular lab, in order for it to work, you have to understand that this is a 100-watt synchronous motor. In other words, it's a third of a horsepower. If you do the math, that actually works out to about 833 milliamps of available current in the armature winding. So if you're running it at anything but that, okay, so right now what I've done just to show you is I have a little over 300 milliamps. We'll put it right at 300 milliamps of field current. Okay, so at 300 milliamps of field current, we're running at full load. Now, if I don't run at 300 milliamps of field current and I turn the field current all the way down, you can see that we're overloading it. It's not going to stay in very long. Your overloads will go. So when you're taking these readings, make sure that you understand that when it asks for you to take it at 0 field current, you're going to turn this machine on, take your reading, and turn it off. Otherwise, your overloads will go. So let's do that. We're going to turn this thing down to 0 milliamps, or as low as it'll go. There we're at 10 milliamps, 1.47 amps of armature current. We're going to turn that off now because this motor, of course, is going to get very warm. So now when we turn it on this time, we're going to adjust it to 100 milliamps and take our reading. So we're going to come over here to our field. We're in synchronization. We're going to come over here. We're going to adjust this up to 100 milliamps. We're going to try and do this rather quickly because, again, we're overloading. We're 1.8. Now let's adjust it to 200 milliamps. Okay, we go to 200 milliamps. About right there. I don't know if it's going to kick on or not. We're at 1 amp. We're still overloaded. Now we're going to go to 300 milliamps. Now, as soon as we go to about 300 milliamps, we're actually below full load on our armature. So we can run this all day long at this and we're okay. We don't have to worry about the overloads tripping out. So now let's go to 400 milliamps. Now again, when I'm adjusting this, I'm actually increasing the strength of the rotating magnetic field and the rotor magnetic field, causing a stronger attraction, less torque angle. All right, so there I'm down to 650 milliamps, well within full load. You can see I'm reaching unity. So here we're going to adjust to 500. There I'm at 500, and I'm down now to 540 milliamps. Now let's adjust it to 600 and see what we get. Adjust the field to 600. There I'm at about 600. I'm at about 0.5 amp. I doubt we're going to get much lower than that. Now I'm going to come over here and adjust it to 700 milliamps. There I'm at 700 milliamps. Now I'm starting to climb up. So you could see that we were at unity at about 600 milliamps, or as close as we're going to get, because now we have a leading power factor. So I'm going to come over here, we're going to go from 7 to 8. There we're at 8. Again, we're climbing over here back up on our armature current. Come back over here, go to 900 milliamps. And we're getting close to full load, so now we're leading again still. We're going to come up and we're going to go to 1 amp. Now again, we have to do this quick because we're now overloading the motor. And because we're at darn near 1 amp. And that basically sums it up. I'll bring it back down to, say, 600 milliamp, which is where about we had unity. And you can see we're down to that 0.5 amp again. So this is, if we're trying to simply run a load, you know, this here would be for power factor correction, anything here above. If I go above 600 milliamp, I'm actually creating a leading power factor, which would be used for power factor correction. If I'm running at unity, what I'm actually doing is I'm running at the lowest current and I'm driving a load without causing any power factor problems, which is probably where we want to be. Hopefully this will help. Again, you can see the picture of this particular connection. You can see that we are using our AC here. This goes out to our starter, and that's where our armature current is coming from. We are using the 8 amp variable supply here to feed the field of the synchronous motor. Hope that helps.